Oops, oops, oops. Oops. Okay, great. Hello and welcome. Thank you all for coming. This is Code Soul. We have a couple of first timers here, right? Or like first or second timers, I believe. So welcome. Today we're going to do a crash course, and I explained earlier, but I'll explain it for the benefit of the stream. We are going to go fast, especially since we're starting a little bit late. You are not going to remember everything, and that is okay. You don't necessarily need to remember every little thing. The concepts are what are going to be the important part, and the fact that you will have something that actually runs will also be the important part, because you can always go back and experiment with it and see how it works, what doesn't work, all these kinds of things. So that is the plan for today. That said, despite us going fast, sorry, fixing the audio here. Despite us going fast, if you run into problems or have questions, please do not hesitate to let me know. Okay, if you're like, Beej, that didn't make any sense, can you explain that again? Cool. Also, when I ask if you have questions, I stop and I wait for an uncomfortably long amount of time to kind of like push you to ask questions, okay? So be prepared for that. Does everyone have, if you're on Windows, did you set up WSL? Windows subsystem for Linux. If not, we can figure something out. Actually, wait, no, they set up, you're right, UV is on Windows now too. Okay, so forget the WSL thing. Did you set up VS Code and UV? Okay, excellent. Sorry, I'd forgotten that they had actually added Windows support, but in any case, it's much nicer to develop in Linux, but it's okay, that can be a later thing. So, before we actually get started with the content, what I would like to do is open up a terminal. So in my case, I'm going to open up command prompt here. And so if you're on Windows, search for command prompt. If you're on Mac, search for terminal. Okay. And let me actually check what the current version is real quick. Let's see. What is the current version? Current version. Okay, cool. And let me. If you did set up WSL, okay, you're on Windows. You see this. You're on normal Windows. You're not on Linux yet. Do WSL. Okay. If you set up WSL and you're on Windows. Okay, so now I'm in Linux. You see all the pretty colors and all that. All right. And you can do UV. Give me a second because I didn't set up my notes here. Yeah, okay.
Could you please make the fonts bigger?
Oh, yes, of course. Oh, there we go. How's that? Is that better? Better? All right. And we're going to do, you can ignore all this stuff. I'm just trying to, yep, great. You can do UV Python install 3.14. Okay? This one you can do on Mac or Linux. Okay? Or sorry, Mac or Windows or WSL. So if you do this, this will install Python for you. Okay? Then you can skip this. Actually, no, I'm sorry. If you have Python installed, you should still do this with UV, because UV can manage multiple versions of Python. The reason why it's good to have multiple versions of Python is because, well, to put it bluntly, software engineering kind of sucks. Some projects work with certain versions of Python, some projects don't. So for example, if you're using PyTorch, which is a big giant machine learning library, doesn't work with Python 3.14 yet. You still need like Python 3.11 or 3.12. So if you could just switch between Python versions, it's much easier. UV manages Python versions for you, which is very nice. Does that make sense? Cool. So now this might be fast, this might be slow. The reason we're doing it at the beginning is because in case it is slow. So yeah, that's probably going to take some time if it ends up needing to build from source. And if so, you can just let that run in the background while we talk about other stuff. Okay? So has everyone got Python installing? Not yet? Do you need help? Okay. No, it's totally fine. That's what we're here for.
Sorry, someone's watching.
Oh, yeah, stop.
Oh,
Don't-
thank you.
yeah.
Sorry.
No, I didn't do anything. All right, great. Has everyone else got Python installing? Spectacular. All right. So let's get rid of this for a second. Let's go back to presentation stuff. That was a lot faster than I expected, so great. All right, so today's goal. We're going to teach you Python, but so that you have something usable that you can tinker with and play with, we're going to build a tool that's going to read like a fake work log. Okay, it's just a CSV file, just a comma-separated value like a spreadsheet, and we're going to analyze it. Okay, so we're actually going to use like a crazy analytics library to do like a basic little group by, but we're going to use this as a way to teach you Python. Okay, so we're going to be like, hey, how many hours did Bob work this week, and be able to analyze that kind of stuff based on some data. All right, so that's our goal for today in terms of what we will build. So far, so good? Cool. So, we're going to cover a lot today. This is a crash course. We're going fast, all right? We're going to talk about WSL and UV, okay? If you're a Mac person, you can just ignore the WSL thing, but I think everyone here has a Windows machine, right? Nope, you have Mac. Okay, are you guys okay, or do you need help? Okay, let me run over there real quick.
I am here.
Oh, awesome. Thank you, Jason. Totally forgot you were there. Awesome. And then we'll talk about navigating the file system. It's not something you necessarily do in your development directly, but you'll end up doing it at some point. So we'll go over it. Then we'll go over how to create a project and the supporting files for that project, along with, let me grab this guy real quick. Yeah. Along with getting into, so that's all kind of like the supporting work, and then we'll actually start learning Python. We'll learn what variables are, how to do math in Python, functions so that you can reuse code and not have to type the same thing a million times. We'll go over conditions, basically how to make it smart, if this, then that. We'll go over loops, how to do things a million times with like 2 lines of code. Then we'll go over collections, how do you store a bunch of data all at once. Then we'll go over classes and objects, which is basically reusable separate components. And then we'll actually dive into a CSV, an external data file, and then use external modules and dependencies, basically code from the internet that we can use to make stuff go. Give me just a second to check something. Okay. Yeah. All right. So any questions about the agenda? All right, let's go. So, WSL and UV. So what is WSL? WSL is Windows Subsystem for Linux. Why do I recommend you use this? Because, to put it bluntly, Windows is not excellent for development unless you're doing development for Windows. Most server infrastructure is running on Linux. And so if servers are running on Linux and servers are where you're going to deploy your code, you should develop your code on Linux. It just makes it so that when you're doing your development environment and your production environment are similar. That is ideal. Now, I'm not saying every service is Linux. Like the first company I worked at, everything was Windows except for the one tiny part that I worked in. But Linux is generally considered easier for automation, easier for management, because in Linux, everything is a file. Everything. Even actively running programs just show up as files. Even if you want to like look at how the CPU is doing, you read a file. Everything in Linux is a file, which is great, makes things easy, but it does have like a bit of a steep learning curve because it doesn't do as much for you as Windows and Mac does. Okay? Now, why do we not need to do this nonsense with Mac? Mac is actually based on Unix. Unix is kind of the grandparent of Linux and Mac. So Linux and Mac share a lineage. A lot of stuff that works on Linux also works on Mac. Not everything, but a lot. So this is why the stereotype of modern software engineers is they're walking around with a MacBook, because they don't necessarily want to use Linux because it's a little bit harder to use as like a user environment, although that's changed a lot in recent times, and Linux is actually pretty nice. Nudge, nudge, wink, wink. The only reason I'm not using it is because of video games. And even that's getting pretty good on Linux. But because Mac is similar enough to Linux, they get the usability, plus having a similar to production environment. But on Windows, Windows has diverged a lot, And so by setting up WSL, Windows Subsystem for Linux, you're basically installing a Linux computer inside your computer. And then you can just do everything in Linux. So that's what we're going to do today. And then UV, what is UV? For a long time, managing Python projects has been less than great. There's been like 3 different package management systems for like managing projects. It's been a mess. It's been a nightmare. So they were like, oh, we should make one project package management system for all of Python. So now we have 4. And that's UV, but UV is very fast. It's pretty reasonable. It does a lot of stuff to protect your dependency management. And it also uses the new standard PyProject.toml, basically a standardized and approved way to manage Python projects that's supported by nearly all of the Python package managers. Now, that may not make a whole lot of sense right this moment, but once we dive into it, it will make more sense, okay? So any questions about this stuff so far? Or commentary and disagreement, because I definitely had some opinions in there. Great, let's go. All right, so first off, we're going to talk about the file system. So especially in, file systems are the same pretty much between Windows and Linux for purposes of our work, except when you see a backslash, it's a /, and yeah. Windows uses backslashes to separate forwards, which is like, what, why? Linux uses /, whatever. I don't know why they changed it. But anyway, this, when you're in like Windows land or even Mac land, if you're using if you're in Mac and you're using Finder, or you're in Windows and you're using File Explorer, it looks like this up top, right? Where's my mouse? It looks like this up here, right? But when we're using the terminal, when we're using command prompt on Windows or terminal on Mac, it's going to look like this. Okay? It's the same thing. It's just that this is represented using graphics. This is represented using text. But it's the same thing. Okay? And this is something that's going to be tricky when you're getting into programming, and also why many people, when they start with programming, they start with front-end web programming. Because there's a separation between what you see and what is. The file system exists whether you're looking at it or not. And these are 2 different ways of looking at the file system. When you're looking at it in the File Explorer versus when you're looking at it in a terminal, they're both making calls to the same underlying system. It's just you can look at it in different ways. And that's true of the back-end world in many, 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 many different ways. All right? So this is something that's really tricky to get into your head, but if you can understand it early, it makes your life way easier. All right? Does that make sense so far? Great. So yeah, terminal is just another way to work with the file system. So just wanted to share, if you guys opened up command prompt or terminal earlier, I wanted to share a couple of commands. Let me actually go in here real quick. Yeah, there we go. So let me also get the hell out of there. And let's clean this up. So what we're gonna do is, okay, I should not be using that screen to do this. Okay, that's still slow and it's going to bother the hell out of me. All right, so I'm going to teach you guys a couple of terminal commands, okay? And these are almost the same between Windows and Linux. If you're using WSL, you don't have to worry about it because you're in Linux. Mac uses the same as Linux. For Windows, it's a little bit different. I'll mention it briefly. So we have a file system, right? What the hell does that mean? That means if you do ls, which is short for list structure, right? Or list system, I don't know. List something. This will list all the files in the current folder. Okay? So you can do that. And that would be the same as, well, let's see if I can do this. Where is Linux? Show me Ubuntu, show me my home folder. Oh my god, home and Beej. There we go. So if you look at, not looking at the hidden folders, if you look at some of the files here, right? So you see like installer.sh, I should probably figure out what that is. You see installer.sh, it's 2 ways of looking at the same thing. Okay? So ls is like opening up this window. Okay? Now, let's say I want to go, let's say I want to have all of my software projects in one place. which I highly recommend. If you don't have a projects folder, you should make one. So we can do that now. You can do mkdir, which is short for make directory, and you can do a projects folder. Now, it's going to complain that there's an error for me because I already have a projects folder. But if you do this, it will create a projects folder, okay? And then if you ls again, you'll see in the list, you'll see a projects folder here. Okay? Is everyone good with that? Cool? All right. So ls is to show files, make dir is to make a directory. That's the same on Windows, actually. Except for Windows, ls may or may not work. dir is the same as ls on Windows. So if you do dir, short for directory, it'll show you stuff on Windows. But I do really recommend setting up WSL, but for later. So now we can use cd to change directory, cd, change directory, into the projects folder. Okay, so then that will be like if I went to here, right, and oh my god, and I double click the projects folder. Where is it? If I double click the projects folder, that's the same as doing cd projects. Okay, and you'll notice that my prompt here has changed to show me that I'm inside the projects folder. If I ls now, if I ls now, it'll show different stuff because I'm in a different folder. Okay, does that make sense so far? So again, double clicking a folder is like doing cd and going into the folder. Jason, can you help her catch up? Thank you. And then looking at the files here is the same as typing ls here. Everyone good? Cool. So now, hopefully you have a projects folder. Hopefully you've gone into the projects folder. Let's see, did I do this the way? Yeah. So now what we're actually going to create a Python project. Okay? So if you have UV installed, what you're going to do is you're going to do UV init, short for initialize, right? And you're, okay? So far so good? Does everyone see something like this after doing UV init? Cool. So now, let's go ahead and cd into that folder. So cd Python crash course, whatever. Now you might not want to type all that. You can just hit tab. Tab will autocomplete. Okay? So now you can see I'm inside that Python crash course folder. It's like I double clicked it in File Explorer. And now I can do ls again to show the files in there. Okay? Does everyone see these files? Everyone see? Great. You guys too? You see these files in here? Excellent. So let's pause for a second from entering commands and explain what the hell we just did. All right. So UV init sets up a Python project for you. What does it mean to set up a Python project? Well, that depends on whom you ask. But fortunately, UV sets up a nice, what I would call complete Python project, rather than a kind of minimal project. So what it does is, the first big thing is it creates the pyproject.toml file. Okay. This one here. And that file defines what is the name of your project, what Python version should it be using, what other software does it depend on, these kinds of things. Okay, pyproject.toml, it's not strictly required for every Python project, but it makes stuff much easier and cleaner to use. Okay, and we're going to look at the contents of it in just a minute. I'm just explaining what it is for now. Additionally, a readme.md. MD is short for Markdown. It's just a way to format text. You don't need to worry about that for now. But the readme explains what is this project? How do you set it up? How do you run it? Okay. Basically, it's kind of the tutorial for your project. It's just a text file that other developers can read. And then main.py. Okay. .py is your Python file. That's where your Python code will live. When we're writing our Python code, that's the file we're going to type text into. Okay? Who here has used Microsoft Word or like Google Docs or something? Right? Everyone? You can write code in those. It won't run, but code is just text. okay, is just text. It's just text that a computer is able to understand, okay? We're not doing like crazy rocket science. You're not typing zeros and ones into stuff. I mean, you can, but no, this is not a good time. So that text file, that main.py, is where we're going to type our code for our Python program to run, okay? Python version is a different way to track the Python version for UV, okay? Because if you have multiple projects on your computer and the different projects are using different Python versions, UV will actually look at that Python version file to figure out which Python version you'll use with UV, okay? Generally, you don't need to worry about that file. And then git ignore. Who has heard of Git? Okay, so a good number of people. So for the couple of you that have not heard of Git, Git is a tool for tracking your code over time and allowing easier collaboration on code. We've actually done a few Git tutorials. If you look on our YouTube, you can see recordings of those. But it's a way where I can basically add checkpoints to my code so that, let's say I do something new that's an experiment and I just mess everything up and everything's broken, but I've saved all my files, right? I can just, in Git, go back to the previous version and kind of save myself. Alternatively, let's say you're working as a team. People can make different branches of software, and they can work independently rather than like, oh, we both changed this file, which one is right? Right? You do that independently, and then you merge all your stuff at once, rather than you overwriting each other's files all the time. Okay? And git ignore tells Git, hey, which files should I ignore? Because you don't necessarily need to track every file. Sometimes you have secret data in your project that you don't want to publish to everyone. Or sometimes you have configurations that are only specific to your computer that don't need to be shared with everyone. That kind of stuff is tracked in your git ignore. For purposes of today, you don't really need to know about it, but when you're looking at it, I don't want you scratching your head and be like, wait, what the hell is that? At least you have some idea, okay? So does everyone understand at a high level what these files are so far? Great. How are we doing on time? Oh boy, we gotta get moving. All right, so let's actually get stuff going. Let's who opened up VS? Everyone installed VS Code, right? You see, you have something like this, right? Okay, great. Crap, I don't remember how to do this actually. What we're gonna do is we're gonna open folder. Okay. And if you're on Mac, you can just navigate to wherever your project directory is. Wherever that UV init thing you did, just go there. Okay. If you're on Windows, it's a little more complicated because of WSL. You can go to, crap. All right. Yep. Yeah. So this is a pain we have to do just the first time you do this. Later it's easier, but this first time it's a little confusing. It'll be easier in the future. I'll show you how. So what you do is // $WSL. Is this right? Let me check because I'm not sure if my memory is correct. Nope, my memory is not correct. Crap. Give me a second here. Nope, doesn't like that. Crap. Sorry guys, give me just a second here. It's been a minute since I've done this. Oh, they changed it. Really? Let's try that. Let's try that. That would be why it didn't work. I mean, unless my memory was bad. Huh. Okay, great. So this might be difficult for you to see, but you can type // WSL.localhost. Can I make it bigger? I can't make it bigger. And then I think that'll still give you like a menu to look through. Yeah. So if you do // WSL.localhost, you should be able to see Ubuntu or some similar thing. // the one above the enter key. Does everyone see this? Yeah? All right. And then navigate to your projects folder. Now, in WSL, usually that's your home directory and then your username. It depends on where you made your projects folder. I'm probably going to have to run around and help each one of you with this. But you can go to your projects folder, and I'm going to look for my Python crash course 2026. I'm going to double click that, and then I'm going to select folder. Yeah. Oh, interesting. Oh, okay. So what I did might not actually work for you guys because I have a different configuration, but I'm going to figure that out. And you should see something like this. But I anticipate you're going to run into issues. So let me run in there and help you out. Who needs help? Okay. We're going to... All right, let's do it. Where is your drive? So you made it in System 32? Whoa. Let's fix that. Why don't I change this? Okay.
No, but that's not true because it's half.
So you just showed that. So what happened was you typed just make directory. So Windows interpreted it as like, oh, you want to make a bunch of directories. Give me all directories. So let's go through.
I'm just a little concerned because you made the directory within Windows. That's why he's putting it on the Linux drive, so we can ask them if it's okay to do that or not. I don't know if it's going to be a problem. It should be okay, but like WSL is a lot better than Python code. I mean, you see my files. We can just. Oh my God.
Anyone else need help? Yeah.
She put her folder within her D drive. Is that okay?
I mean, you're just going to do it on Windows directly?
I think so. Okay.
Then yeah, whatever.
Yeah. She has all the stuff installed, but she put her folder in the D drive.
Yeah, we can fix it up on that later. All right, everyone's good to go? If she didn't do the... Oh, my six. Oh, yeah. So everyone's got VS Code open. Everyone's got their project open in VS Code, right? Spectacular. All right. Whew. Okay, that was the most difficult part to get everyone working on. So, do you guys still need a hand, or are you okay? I'm going to let Mike take care of her, because Mike knows his stuff. All right. So, congratulations, you've made your first Python project. Very good. In the future, what you can do is you should be able to, and you don't have to follow along with this, I'm just going to show you how. Mouse, please. Please? Please, mouse? Okay, fine, we'll do it this way. Where is my terminal? Okay, there's my mouse. Great. At some point, or later on, next time you do a project, you can just do, let me just pick a random project here. Yeah, I don't know. Backend. I don't know what the hell that is, but I'm going to go into this backend project. And you can just do code from the project folder, and it'll open up VS Code for you. So that'll be much easier rather than having to do all this crazy, like, WSL, localhost, all that kind of stuff. But there's 101 different ways to do it. Find a way that works for you. Okay? All right, so this is our Python project, okay? If you open up main.py, you'll see that it's already written some code for us, okay? So it saved us a bunch of time, all right? Now, let's actually make sure that our stuff runs, okay? It is a very, very important, emotionally, tradition among programmers that when you set up a new environment for the first time, you create a program called Hello World, where its whole goal is to just print Hello World to the screen. Okay? So that's what that's what they have written for us. So let's test it. You can go to, in VS Code, you can go to terminal, new terminal, and you should see a terminal show up here at the bottom. Whoa! Crap. We didn't open this up correctly. I'm sorry, guys. Give me a second here. I messed something up. Why is it doing it as a network? No. Yeah?
I think if we put the dollar symbol at the end.
At the end?
Yeah.
That's my man. Let me double check. Let me test this before I give you guys guidance on how to do this, because it may or may not be correct. Because they keep changing stuff. I don't know, whatever. No, I'm not. That's not my project. Yeah, this will work. Okay. Okay. Hopefully you see a folder, reopen folder in WSL. Did anyone see this or no? No one saw this? Okay, skip it. So let's try in your terminal, if you still have your command line or your terminal up, in your project folder. Nope. Where the hell is it? Yeah, why? Ugh. Okay, there we go. So in your project folder from terminal, if you do code, that should run VS Code. And there we go. Now it's running in WSL. For those of you, so for those of you on Mac, you don't got to worry about this. You're good. If you're using WSL on Windows, you absolutely want to run it this way. Otherwise, stuff's going to get real funky. Okay? So let me take a look at your guys' stuff and make sure you're all set up. I'm going to explain why in a minute. Sorry, folks. Sorry. So if you don't have to close and reopen the project and all that kind of stuff if you're on WSL, you can just open your thing from recent, and then in your terminal down here, if you're on Windows and you don't have WSL stuff set up properly, it's going to open a PowerShell thing. You don't want that. Okay? That's a bad time. If you get this reopen folder in WSL, go with that. Again, if you're on Mac, you don't need to worry about this. If you don't see this, what you can just do is if you see this little plus button right here, there's an arrow next to it. You can click that, and you can go to Ubuntu WSL. If you do that, now you're in Linux land. Okay? Again, if you're on Mac, you don't got to worry about any of this. That's why a lot of developers get Macs. But is everyone able to get this? All right, you good? Mike, do you two need help over there, or are you okay?
Just getting your project set up.
Okay. All right, great. So now let's get back to actually learning Python stuff. So, oh, right. We were going to run the program. So now, if you've got this, go ahead and do uv run main.py. Okay, this will actually run your Python program. And you'll see it says, hello from Python Crash Course 2026. Everyone's good? Yeah, all right, cool. Oof, that's the scariest part. The rest of this is easy. Good? All right. Mike, are you two okay? Do you need a hand?
So I just initiated the WSL stuff. Just installed the system.
She installed WSL. You only need to do it once. Don't worry about it. All right. So go ahead and because are you finished? Maybe.
There, but it's not native.
Okay. So for now, just go ahead and direct your attention back up here because now we're going to get into actually learning Python. All right. So let me get the presentation back up. All right. So Python. We're just gonna. There's a whole bunch of stuff I could tell you about what exactly Python is, how it works, and all that. But honestly, while that's really important for once you do real world stuff, the goal here is to just get you coding Python. So we're going to skip all the academic stuff and we're going to go right into how to write some code. All right. So the first thing you need to know is variables. Who has taken algebra? Hopefully everyone here, right? Who remembers algebra? A couple of hands. All right. Coding is a lot of algebra-like stuff. Okay? So the core thing in programming is, well, I guess that's not core, because there are languages that actually don't have them. But for our purposes, a core thing are variables. Okay? What the hell is a variable? It's just like algebra, right? You have some symbol, like x, or my variable, or whatever the hell you want to call it, and it stores some value that can change over time. Now, the difference between algebra and programming is that in algebra, it's only a number. In programming, it can be anything. Which you're like, well, what else is there? Oh, you're going to see. Another way I like to explain variables is you can think of a variable like a box with a label. Okay? And that label is the name of the variable. And you can put whatever in the box, you can take whatever out of the box. And you can put the label will remain the same. What's in the box is going to change all the time, but the variable is a way to reference something in that box. Okay? So that is a variable. So it's basically named data storage. Okay? Now you can store numbers like in algebra. You can store text. You can store objects, which you don't know what that is yet, but we're going to explain it later. You can store collections, which is a bunch of which is a bunch of numbers or text or objects. You can store Booleans, which are true, false, and we're going to cover this in a couple minutes. The type doesn't matter. Why am I saying that? Because maybe some of you have experiences with other programming languages, and those programming languages are strongly typed, and it's like, only this type can go in this variable. Python does not care. You can store a number in this variable, and then later you can store text in that variable. And then later you can store a true-false value in that variable. Python doesn't care. I don't recommend it, because then your code can get confusing, but Python will let you do that. And it's kind of the most basic element in programming. Like, it's just, here's a box, here's a thing, done. And you use it for a lot of other stuff. The reason I mentioned that's the most basic element is because if you don't understand variables, you're going to have a bad time. So it's important that you get this. And then a lot of people will, when they're describing code, they'll say x equals 5. I really recommend people to not read that way. X does not mean, or sorry, equals, the equal symbol does not mean equality in terms of math. Okay, I recommend you think of it as assigned. Okay, so x is assigned to 5. Okay, so 5 gets stored in the x box. Okay, does that make more sense? Very good. So for example, in Python, I could write x equals, and then in quotes, dashend. And that would, okay, does someone want to volunteer for how would you read that based on what I told you the equal symbol is? Come on, guys. Sorry? Yeah, that works. That works. X is inside the X box, or sorry, dashend is inside the X box, yes? You could also say X is assigned to dashend. Okay? Cool. But thank you. Excellent. So, let's actually try that. Okay? Sorry, one more thing. Why is dashend in double quotes? Because if you just have some text without quotes, Python will think it is a variable or function. If you have it inside quotes, it's going to be like, okay, this is text data that I'm going to do something with. Okay? That confuses people a lot at the beginning. If you want to use text as data and do something with it, you need quotes. Double quotes works, single quotes works, either one is fine, but you need quotes. Okay? All good? All right, so let's go ahead and go back to our code. Where is my thing? There we go. And what I want to do is inside this main function, okay, which I know that doesn't make a lot of sense, but just go with it for now. Let's add a new line, and you'll see it preserves the indentation here. It preserves this indentation. Keep that, okay? Just let the indentation be, and let's say x equals dashend, or no, do your name or something. So I'm gonna say x equals beej. All right, and then I'm going to use a print function. I know you don't know what it means yet, but just allow the magic for now, okay? And type print x like this, okay? And then instead of beej, type whatever you want. Okay, everyone good? Everyone's got that? All right, so now come back down here, and you can type uv run main.py again, or if you're an engineer, laziness is a virtue. Just hit the up arrow and hit enter. Up will bring you the last command. And then you should see it'll print whatever you stored in X, in this case beej, in the command line. Does everyone see that? Has everyone got that on theirs? Do you need help, Lauren? Okay. You got it? Yeah, you got it. All right, is everyone else okay? Good? All right. Mike, are you two okay over there?
Yeah, I'm just getting Python installed and running.
Okay. Wait, getting Python installed and running?
No, Python.
PyM?
Yeah, it's on WSL by default. I didn't install it.
Oh. Well, we're okay.
You're using it in the shell, right?
Okay. Yeah, but it's fine. It's fine. Yeah, we're good.
Should I just UV run?
I mean, she set up UV on Windows, so we were just going to do that, but whatever, it's fine.
Oh, alright. Let's do that then. It's faster.
Yeah, whatever works. I mean, if she gets WSL set up, that's going to be an easier time for her later, so.
Okay. Well, I could just
Let her choose. Let her choose.
whatever's easy.
All right. So, and you can change. So what we can do is later we can say x equals coding is fun, right? And then we can print x again. All right. Now you don't have to write this. If you want to, you can. And then if I do UV run again, you see it'll print Coding is fun. Okay, so you can change what is in a variable over time throughout your program. And with some exceptions like functions, which I'll explain in a minute, programs usually run top to bottom. Okay? So first line, then second line, then third line, then fourth line. We call this imperative programming. But yeah. So is everyone able to get a second line going? Or right, you don't have to do that, but it's up to you. Good? What's up?
Do you need to rewrite print, or it understands that you're overriding the variable is?
You have to rewrite print. So here's the thing, and this is what's tricky. The computer will do exactly what you tell it to do, and only what you tell it to do. So if you tell it to print once and then you do something else, it's just going to print once and do something else. If you tell it to print again, then it'll print again. Does that make sense? Cool. So a fun exercise that a lot of programming instructors do is like, hey, tell me to make a sandwich. And then you say, oh, take the bread out. And then they like grab the bread and then they throw it out the door. Because you weren't specific enough. It's been like, no, open the bag of bread. And then they just tear open the bag. It's like, oh, no, okay. Undo the wrapper on the bread opening. And then they do that. And you're like, okay, spread open the opening. Okay, reach into the package and take out the loaf of bread. This kind of thing. Okay, you have to be very explicit with every step. So far, so good? All right. So, variables, good. Now, this is a little bit of an aside. We don't need this all the time, but it can be a little bit confusing. And when you're going through a lot of tutorials, you'll be like, what the hell? So we're going to explain, how do you do math in Python? Okay? Because, addition, subtraction, those are normal. Those are fine. You have addition, subtraction symbols on your keyboard. No problem. There's also multiply. Okay? But if you just type x, like, 4x10, 4 times 10, right? That doesn't work because it's going to treat x like a variable or text or whatever. So in programming, we often use the star symbol, the asterisk symbol, Shift 8 on a Korean or US keyboard, as our multiplication symbol. Okay? And then a /, the one left next to your Shift key on an American or Korean keyboard, to do division. Okay? Now, this isn't critically important for today, but later, if you need to do math stuff and you're like, wait, why is like 4x10 not working? You're going to be pulling your hair out, and I want you to avoid that. Also, if you want to get the remainder, there's a special operator for that called modulo. You can just use the percentage symbol for that. So 3 percentage symbol 2 would give you 2, because 3 divided by 2, or let's do a different example. 3 percentage 7 would give you 1. Because 7 divided by 3 is 2 with a remainder of 1. Okay? So this gives you the remainder. And then floor divide does division, and it returns the whole value and it drops the remainder. So if I did 7 / 3, right? Then it would give me 2. Because again, it's 2 remainder 1. It just drops the remainder. Okay? Now again, not super critical all the time. But later, when you need to do some math, you'll be really happy you know this. You can just look this up as a reference. I just wanted to make sure you're aware that this is a difference. Okay? All good? Cool. We don't even need to do an example because it's not important for today. All right, so moving on. Functions. All right? We're actually pretty good on schedule, I think. Functions. Functions are how you keep from writing the same code 100,000 times. All right? Basically, what you can do is you can have some code written, give it a name, and then rather than write all that code every time, you can just use that name. And then that code kind of gets inserted at that location. Okay? So basically you write the code once and you can use it many times. All right? There's a specific syntax, a specific set of symbols and operations you must do in order to define a function. Okay? Functions start with def, short for definition. Then you give them the name, whatever you want to name the function. And I do recommend giving a descriptive name, even if it's long. Okay? You might not be the fastest typist, but we have autocomplete. Okay? So if the name is long and descriptive, much better than like def A. I had a computer graphics course in university, and the professor gave us a library of a whole bunch of graphics functions, and every single goddamn function was P, uppercase P, L, uppercase L. That was a nightmare because you couldn't tell if it was lowercase l or an I, because he had functions for both. So please don't do that. If you do that, I will find you. Okay? I'm joking, of course. And then after the name, you put parentheses, because a function can accept inputs to change the behavior of a function, okay, which we'll talk about later. But you do parentheses, and then you can list your inputs. You can have as many inputs as you want, and the inputs basically act like variables, okay? Now, I used A and B here because they're meaningless. Please don't just use A and B. Please give them actual descriptive names, and you separate them with commas, okay? And then after the parentheses, you have a colon, and that says, okay, this is the top-level definition of the function. Now we're going to tell you what the function does, okay? And then after that, you do a new line, and then you have to have indentation, okay? So that's a lot, and Visual Studio Code helps you do a lot of this for you, so you don't have to remember every single little thing. It helps you write a function, okay? Now, important thing, if you have used a different language, okay, like C or Java or whatever, white space does not matter, right? Use curly brackets and all that kind of stuff. Python, no. If your indentation is wrong, your program's going to explode, okay? So white space matters. If you define a function, the next line needs an indentation so that Python knows that whatever code you're writing is part of that function, okay? So any code that's part of the function needs to be indented immediately beneath the function, beneath the function name, okay? I'm going to show this to you in a minute. And then later, when you want to use that function, you just type the name again, do parentheses, and say which values you want to set for those inputs. That may not make a lot of sense now. I'm going to demonstrate it in a second, okay? But conceptually, does that make sense to everyone? Cool. Let's try it. So what we're going to do is, mouse, please. Okay, great. Is after our main function here, okay? Now make sure that there's no indentation, okay? You should be at the very left edge of the file. I'm going to add a couple of new lines just to make it clear. And I'm going to do, and please follow along with this part. We're going to define a function called add, okay? So we're going to say add here, okay? And then we're going to do parentheses. And just because I want you to get in the practice of having long descriptive variable names, we're going to have first number, comma, and space. You don't strictly need the space, but it's a good idea for readability. Second number. And then close parentheses. I know not everyone types as fast as I do, so I'm waiting a moment. And then after that, you can do colon, and then enter. Now you'll notice Visual Studio Code is smart. It sees that once you have that colon, you're defining a function, so when you hit enter, it gives you indentation, because it knows you want to input the contents in the function. Okay? So now, I'm going to explain what this means in a second, but just type return first number. Whoa! And it has to match the text exactly. Use the autocomplete, okay? There's no reason to type the whole thing yourself. And then second number, autocomplete. Whoa, whoa, whoa. Except I did not type that correctly. It should be plus, not comma. Apologies. Okay? Is everyone going to have that? Great. And then I should have done it in the main function, but I accidentally defined this after the main function, so oops. This is bad practice, but just go with it. And then we're going to do output equals add, let's do 3 and 4, and then print output. I'm going to explain what that part means in a second, okay? So I'll give everyone a moment to get this typed out. Can you guys, do you need me to make the, here, let me make the text bigger, because I see a couple people squinting. Whoa. Whoa. Sorry, guys. Whoa. Okay, there we go. Has everyone got that? Okay, I see a few people still typing. Good. Good, good, good. We're doing okay on time. All right, so then like before, just up, enter. And you'll see it should print 7, or the addition of whatever numbers you used. Okay? Good? Cool. Does anyone need help?
No, it's not printing.
It's not printing.
It should be sending other people to it. Say, oh, make sure you say file.
Ah, right.
So,
Try it again.
obviously it might not be on by default. Right, so RAM is not 7 seats. You messed up. So it's a good object lesson, right? Also, you can't have this white specific. So like it converts or it interprets the text. It converts those spaces into tabs and formats. So if you don't have why you write that stuff down, you don't have the proper spacing. It's like putting letters down. Just makes it happen.
No, because I actually
Oh.
tried first one for the second.
And press up. So like the up arrow. Just not much. And it will return the last one. And
I'll explain.
All right, so I'm actually very glad. Ow! I'm very glad you had those issues because that caught a couple things I need to explain. So first off, if you make changes to a file, okay, you should notice up here you get a white dot. Okay, that I want you to get in the habit. That white dot should make you very nervous. Because that white dot means that your file is not saved. Okay? If you see the white dot, you should be nervous. All right? Now, because I've been programming for years and years and years and years, I don't even think about it. The moment I finish typing a line, I hit Control S. It's muscle memory at this point. Okay? So I apologize for missing that. It's so ingrained into my being that I didn't even think about it. So I'm glad you had that issue. Yeah, Control S is to save. You should instinctively be hitting Control S every few seconds. Okay? The reason is, if you don't save the file before you try to run it, it's not going to work. All right? Secondly, when you're using function names, okay, they must match exactly. Okay? A capital P will not work. Okay? All right, now to the stuff that I was planning on explaining once we got this running. So you got something running, it works, you kind of understand maybe how a function is defined, but there's probably a bunch of pieces that don't make sense. I'm going to explain those now, okay? So, this first number, second number thing, okay? Basically, we are defining variables that the function will use. But we do not assign the variables at the function definition. We assign the variables when we call the function. Okay? This down here is when we call the function. So the first thing in parentheses gets assigned to this variable. So first number gets set to 3. Okay? And second number gets set to 4. Purely based on their position. There are other ways to do this. You can do named variables and you can do different types of assignment. We're not going to cover that today. Okay? And then, basically, first number becomes 3. Second number becomes 4. What is 3 plus 4? Not 9. 7. And so, what happens is, when you call a function, okay, if the function has this keyword, return, whatever comes after return, whatever comes after return gets substituted in place of the function call. Okay? So here is the flow of how this works. Output equals something called add with parentheses. Python sees, hey, there's parentheses after some text. That's a function. It looks through the code. It looks for something that says def add. Basically a function defined as add. It finds this and it goes, great. Do you have any parameters? Yes, you have one parameter. Okay, have I been given a parameter? Yes, I'm going to set first number to 3. Do I have a second parameter? Yes, I see a comma. Let me grab the second number. And then the second parameter gets set to that. Second number becomes 3. Okay? And then it goes to the first line. It says, okay, I see return. I'm going to stop running after this line. Return will end a function. Okay? If you do anything after the return line, it's not going to run. All right? Then first number gets substituted for 3. Second number gets substituted for 4. Any evaluation, like addition, like using the plus symbol, happens. So this becomes 7. And then it says, okay, I'm returning 7. So wherever I was called from, this gets replaced with 7. Because 7 is what comes after return. And then so output equals 7, print output, and then we get 7 printed. Does that make sense? It is okay to say no.
No, yes, but if you want to print first number,
Hmm.
then yeah, it won't work, right?
You could. You mean if I typed here print first number?
Yeah.
Correct. Excellent observation. That would not work because first number only exists within the context of this function. Excellent, excellent observation. That is something in programming that we call scope. Okay? First number exists within the scope of this add function, and otherwise it never exists. But if I did this inside the add function, and when we say inside, we mean indented and underneath it, right? This works. You see there's no red line. Because first number does exist, we can use the print function here. Everything is okay. Excellent, excellent question. Other questions? Also, should I be nervous right now?
Yeah.
Yes. Why should I be nervous? White dot. Very good. Thank you. All right. Other questions?
But then how do you assign the variable first number so you can call it for any other function?
I'm not sure I understand the question. Can you say it again?
So if I want to use first number as a variable to use it in another function, as abstraction,
Ah.
how do I assign it?
So what you would want to do is you'd probably want to give it a different name to distinguish it, okay? Because of scope, it just can't exist there. So I could do my number equals 3, and then I could do this as my number. And then if I call another function, like if I call add again, I can do 10 and my number. Does that make sense? Excellent. Very good question. Other questions?
The my number, is it like the global variable in JavaScript? Because you declare it at the top level.
Yeah, so scope in Python is a little bit different from JavaScript, but at this beginner level, let's say yes. In more advanced stuff, no, but we're not going to get there today.
Python doesn't have global variables.
It has module variables. And we're going to cover modules at the end, and I'll come back to it then. Does that sound good? Cool. All right. Other questions? These are excellent questions. Yeah? What the computer doesn't know what add means. Add is just a name. So I could call this monkey, right? And what? Oh no! Oh my God! What am I doing? Sorry, I'm actually not used to using my keyboard. I usually have an external keyboard, so my muscle memory is betraying me. So I could redefine this as monkey. Still works. It's just a name. Yeah. The computer has no idea what the hell add is. Yeah. There is actually a function called sum, and that's why I didn't call this function sum, because I didn't want to use the same name. Yeah. So we'll call, let me call it monkey add, just to remove any kind of ambiguity. Yeah. All right. Other questions? All right. So let's go back to presentation things. We're getting a little bit tight on time, but we'll be okay. So now we have a program. We can store data. We can execute functions and reuse our code. Great, great, great. But I want my program to be smart. I want it to make decisions. How do we do that? We do that with conditions. Okay? Conditions allow you to check some statement, determine if it's true or false, and then take some action as a result of that. Okay? Just like if I have a red light and a green light, and the red light's on, and I say, hey, if the red light's on, jump up and down, and then I turn on the red light, what are you going to do? I see you mouthing it, say it. Exactly, right? Same thing with a computer, okay? So Python has if, else if, but they just write elif because, God forbid, we type. And then else, okay? Now with a condition, the only required part is if, okay? But you can't have elif and else without if. Okay, so everything starts with if you want to use a condition. Now you can also nest things, okay? So you can have a condition that contains a condition, that contains a condition, that contains some code, that contains a condition, if you want. You can go as deep as you want. And so your indentation will increase, okay? And I'll demonstrate that in a moment. And then you also have different operators, okay? Because conditions only understand true and false. If you do if 5, it's going to be like, well, 5 is not 0, so I guess it's true. And it'll interpret 0 as false. But otherwise, it usually wants to work with only true and false values. So usually use comparison operators, like greater than, less than, or there's another operator, 2 equal signs. Means, is it equivalent to? Okay? Again, not equals, because there is no equals, all right? And when you do these comparison operators, it operates like a mathematical function, right? And evaluates to either true or false. That's it, okay? Additionally, you have conjunctions. You can use and you can use or. You can also use not, all right? And that way you can manage your Booleans more effectively. So true and false is false. True and true is true. True or false is true. False or false is false. You could just reference this table. When I first learned programming, this was like super confusing for me for some reason. I don't know why. When I explain it to people these days, they're like, yeah, that makes sense. And I'm like, why was I so dumb? But yeah, so far, so does everyone understand high-level concept? You ready to try it? All right, let's go. So, what we're going to do is let's go back to our main function, okay? And we're going to let's set a variable number 5 because I'm very, very creative, and let's set it to 5. All right. Now, why am I doing it as a variable rather than just doing the raw number? Because I want you to get used to using variables for things. Usually having numbers scattered throughout your code is, we call it a code smell. It smells bad, it's not good. Okay, so use variables. And they're going to have a bigger number is 10. And let's just start with that for now. Okay? So what I'm going to do is if number 5, again, use autocomplete. Autocomplete is your friend. I want to check if they're equivalent. Okay? Equivalency in Python is 2 equal signs. Now, real quick, I'm going to pause for a second because there's something I should have taught you earlier and I forgot. I was actually going to make a slide about it, and I forgot to, so I apologize. But let's go to the line above. I want to teach you something very important. You've probably wanted to take notes, and you probably have a separate application to be taking notes or taking notes on your phone or something, right? You don't necessarily need to do that. It is good practice, but you can actually take notes in your code. If you do the hash symbol, anything after this symbol on this line is ignored by Python. So you can use it to take notes. So I can say double equals is equivalence. Okay. Are these two things equivalent? Okay. Now you can write a note that makes sense to you in the language that you prefer, but you know, I just want to make that clear. So we can check if number 5 and number 10, or sorry, number 5 and bigger number are equal. I'll give everyone a second to catch up because they're probably writing a bunch of comments now. Ooh, I'm getting a bit tight on time. We're gonna have to go faster. Good? All right. And then we can say print 5, whoa, missing my parentheses here. 5 is bigger than 10, which is obviously not true, right? And then we can say elif number 5 is less than bigger number. Print 5 is less than 10. So far, so good? Let's get crazy. Let's get crazy, guys. If bigger number modulo, oh, you didn't expect this one, did you? Modulo number 5 is 0, print 10 is divisible. Whoa, divisible by 5. Yeah.
You're doing equals and then you're doing bigger than, and you're comparing equals and doing bigger than.
Oh, thank you, thank you, thank you, thank you, thank you. I'm sorry, guys. I'm so sorry. I messed up this thing here. Oh my god. Thank you so much. Thank you, thank you. I messed up this text here, so yeah. This is why you don't just blindly accept what AI tells you, because even humans make mistakes. And AI is modeled after us. Oh, and that was something I was going to mention at the beginning, but forgot. It's okay. All right, and then finally, let's do else. Print 5 must be bigger than 10. There we go. That's what I was getting ahead of myself. This is a lot. I'll give you guys a minute to type. Please give me some sort of signal that I know you're done. Good? Good? Good, good? All right, and then check if you should be nervous or not. Okay, make sure to save. On Mac, Command S, on Windows, Control S. And then let's go ahead and run the program again. And what do you think it'll type? What do you think it'll print? Or tell me what yours printed. Who wants to volunteer? No one wants to volunteer? Or someone ran into problems. So it should print 5 is less than 10, 10 is divisible by 5, and then 7 because it's left over. Does anyone need help? Good? Also good? I see some nodding. Excellent. All right, so let's go over what the hell this does. So first, we check if 5 is equivalent to 10. It is not. So what happens is Python checks this here. This evaluates to false, okay? Because 5 is not equivalent to 10. So what it does is it sees the colon, and it sees this indented code, which means it belongs to the colon line, okay? And it skips it, okay? It sees an elif. Now the L will only be triggered if this one is false. Okay? If this one is true, it's going to skip the L. Okay? And because it's an L if, it's like, okay, the one above me has to be false, and I have another condition to check. So it checks if 5 is less than 10. Is that true or false? True. Okay, great. And so then it goes, okay, this is true. The indented things underneath here, I will execute those. So then it goes to the next line. It prints this. Then we see a new condition. Okay? This condition is completely unrelated to the other conditions. Okay? Except that it only runs when this one is true and this one is false. But otherwise, it operates in isolation. And we check if 10 divided by 5 has a remainder. It does not. It's just a simple 2. So what we do is we do a mathematical operation that evaluates to 0. And we check if 0 is equivalent to 0. Okay? Now, this seems very trivial. This is actually a very important calculation, especially if you're doing like front-end development work, because often you'll calculate if a number is even. So how do you do that? Even or odd. So how do you do that? You do the number modulo 2. If the result is 0, it's even. If the result is 1, it's odd. Very, very, very common. Okay? And then in this case, 10 is divisible by 5. So this evaluates to 0. 0 is equivalent to 0. And then we print this. Now, because somewhere in this chain of if and elif, somewhere it looks at the else after this. Because one of them above it was true, it skips the else. Else only runs if all of the ones in this chain are false. Okay? Does everyone understand that so far? I hope people are writing comments. I see a lot of typing. I'm guessing that's what you're doing, and awesome. That is excellent. All right? Any questions? But Beej, what if there's multiple elif? Can you do that? Yes, you can. What if I do an if and then another if? They're completely unrelated. Okay, so you can have an if, an if, an if, an if, and then an else, and the else will only care about the very last if, because ifs are independent of each other. Okay? Any actual questions?
In your scenario, just to clarify, if you chain multiple ifs, let's say you do if something, if something, if something, elif, else, and the first couple ifs are true, what happens?
Yeah, so if you do something like this, right? This will operate independently. So this will just print a blank string. This will skip because false is not true. And then this will operate just how we described. Okay? So these are completely unrelated to this. Okay? Ifs are completely independent of each other unless they're nested and then code execution path. Okay? So what happens is when we have this kind of thing, we actually call this a path. Because depending on the state of the code, it may take the path through this logic, or it may take the path through this logic, but not this logic, or it may take the path through all of this logic, or it may take the path of this logic, depending on what these values are. Okay? Does that make sense? Cool. All right, so I should be nervous. Great. All right, so we're getting tight on time, so we're just going to move forward. Oh, right. Sorry, one last thing. You can also do if not true would evaluate to false, and so it would not run. Okay? You could also do if 5 is equivalent to 5 and 10 is equivalent to 5. this would evaluate to false, because both of them are not true. Okay? You could also do or, right? This would evaluate to true, because one of them is true. And if you want to do multiple, so let's say I do and 10 is equivalent to 10, but then I only want to check if this is true or if all of this is true. You can use parentheses. Oh. Hello, BMP Systems 2014 on the stream. You can learn it right here. That's what we're doing. Otherwise, you can just search online. He's asking, or the person is asking where to learn Python in YouTube. That's why I'm doing this. So yeah, if you do this, this whole thing will evaluate, and then it'll check this OR. So the part inside parentheses will run first, and then outside parentheses, just like algebra, right? Parentheses, and then exponents, and multiplication, division, addition, subtraction. Wow, that was like a really long time ago. All right, all good? Okay, cool. So back to the fun stuff. Loops. This is where computers really shine. Because you and me can do if-else kind of nonsense, right? But if I say, do this 1,000,000 times, for you and me, that's going to take a while. For a computer, it's done already. All right? So loops are where the power really comes in. So let's go ahead. So there are two ways to do a loop in Python. You have for, and you have while. While is actually a little bit simpler. While some condition is true, repeat. Okay? So for example, if you want to do something forever, you just do while true. And the whole thing will just repeat. So for example, let's say you want to run a web server. And you want the web server to always be checking if a request has come in, while true, and then you build the rest of your server. Okay? For is for each item in some set of items. Okay? Now it doesn't have to be a set specifically, but for each item in a collection of items. Okay? So there's a range function, which I'm going to explain. But when you want to do something a fixed number of times, you can just do for I in range and then the number of times. You can just memorize that as a formula. It's really simple. Okay? Additionally, you can do for loops, inside for loops, inside for loops, inside conditions, inside for loops if you want. All this stuff can nest as many times as you want. Make sense? Great. All right, so let's actually write some code. Got to get moving now because we're getting tight on time. So let's do after all of our condition stuff here. Let's make sure we only have one indentation, and let's do for I in range. Make a really big number. Okay, it doesn't matter. Just make a big number. And then colon print. You are so cool. Because the computer loves us. All good? What do you think is going to happen when we run this? If you put too many numbers, it might actually explode. But if the number's not too big, it's going to write, you are so cool, a bunch of times. Now that number's probably a little bit too big, so it's going to take a while. But here's a good lesson to learn. Say your program is stuck, or maybe you accidentally did an infinite loop, like while true, when you weren't expecting it. What you can do, and this is true on both Mac and Windows for the exact keys, you can do Control-C. Control-C will interrupt the program. On Mac, I think it's Control-C by default. If not, try Command-C, but I think it's still Control-C by default unless you change things. But yeah. So is everyone able to get their loop to run? Let me change this to a more reasonable number like 3 and run it again. And you'll see it prints 3 times. Okay? Is everyone good with that? Spectacular. So now, let's do a while loop just for demonstration. So let's set, actually, wait. I'm sorry. We're not using I, right? You are so cool, comma I. Let's do that. That way we're actually using that I variable. Because what happens is, in the for loop, what it's going to do is, range actually outputs a number each time you call it, or each time it runs in the loop, right? And so I gets set to the first number 0, gets set to the next number 1, gets set to the next number 2. Now you might be like, wait, whoa, gets set to 0? Yes. In programming, we start counting at 0, okay? So often, if you see someone listing rules and they say rule 0, they might be making a programmer joke, okay? We start counting at 0 because range 3 will output numbers. It'll output 0, 1, 2. If we did range 5, it would do 0, 1, 2, 3, 4. I'm still doing it 5 times, but because I'm going 0 to 4, it's the same, it's still 5 total digits. Does that make sense? Great. So now, let's make a new variable called counter. Let's set counter equal to 100. Okay? And let's do while counter is less than, I don't know. Yeah, let's just do 105. Okay? And then we can print counter. And then I'm going to show you something new here. Okay? We're going to do plus equals 1. Okay? Does that make sense? Can someone describe to me what's going to happen here? Okay, I'll just explain it.
Counter hits 100, adds, while it's countered, prints out counter, adds 1, updates the number, goes back, does it again until it hits 105.
Yeah. So counter is initially set to 100. The while loop triggers. As long as counter is less than 105, it'll run the indented code beneath it. Okay? So 100 is less than 105. So it'll print counter, which in this case is just 100. Then we'll add 1 to counter. And then it'll go back to the beginning of the while. Now counter is 101. Is 101 less than 105? Yes. So it'll run again. And it'll do it again and again until counter becomes 105, or 105, emphasis, which is not less than 105. And then it will cease running and it'll move to whatever's after the while loop. Okay? Does that make sense to everyone? Cool. All right, we're getting really tight on time, so we're just going to move on. There's more about loops, but in order to understand more about loops, I have to teach you about collections. Okay? Collections are how you store many values into one variable. Okay? So there are 4 main types of collections. Okay? There's list, dictionary, set, and tuple. And I'll explain these. A list is just a bunch of items in some order that you define, and you can add some, you can remove some, whatever. Everything's cool. It's just a bucket of things. Okay. A dictionary is a little more complicated. So this one right here is a list, and the values can be any type you want. Okay. And then you have a dictionary where you have some key is referencing some value. So if I were to say, hey, myDict, give me the value for A, it would give me 7. Okay? Then there are sets, which are used a little bit often, or a little bit less often, sorry. Sets only store one copy of a value. So if you want to ensure things are unique, you use a set. So if I do, hey, my set is 1, 2, 2, 2, 3, 4, it'll just say, hey, 1, 2, 3, 4. You gave me like 3 2s, I don't care about that. I only allow unique values. Okay? And then tuple is when you have a list of things and you can't change them. When you set the tuple, that's it, you're done. Can't change it. Okay? Now, in practice, most of the time you're going to use lists and dictionaries. Sets and tuples are much less common. Okay? Now you can also nest all this stuff. So you can say like, hey, I have a dictionary where I have a fruits key and then the value is actually a list. And that list contains the dictionary. So you can put everything inside each other. Okay? So you can have a collection of collections of collections. And these work really well with loops, which we're going to demonstrate in a second. Okay, so does everyone understand the concept? Great. We got to go a lot faster. Whoa, 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 whoa. So what I'm going to do is I'm going to get a list. I'm going to do fruits as a list. I'm going to do banana, orange, and apple. I should also learn how to type. And then I could say for fruit in fruits, print fruit. I'll give everyone a moment to type. Oh, I'm getting hungry. Who's joining for food afterwards? Good. All right. So, basically what this does is for in, we'll use a collection. This is very, 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 very common, okay? Get used to this one. It's also very useful. So what will happen is the loop, when it first runs, will set fruit to the first value in the collection. So fruit is equal to banana. And then it runs the contents of the loop. Then it goes back to the beginning, and it says, okay, I use the first value. What's the second value? The second value is orange. Okay, so I'm going to set fruit to orange, and they're going to run the contents of the loop. Okay? Make sense? Everyone's cool with that? All right, now there's another thing we can do too. Or wait, no, I'm sorry. So sometimes you need to know where in the list it is. Is it the first item, the second item, the third item, whatever? Okay? You can use this enumerate function on a list, okay? And it will output not only the fruit, it will also give you the position, which we usually call the index, okay? Index and position are largely the same. Yes? Thank you. Index is not a special word, it's just what we typically use. You could also just call it position, right? So let's just do position for now. But yeah, it can be whatever word you want. Okay? And that will print the position. And again, remember, in programming, we start counting at 0. Okay, so 0, 1, 2. All right? And then a couple of other things that are important for lists, right? You can do fruits, or we can print fruits, and then we can use square brackets to say I want to pick out a specific one. So we can say I want to print the fruit at index 1. Now we start counting at 0. So which position is index 1? Yes, the second one. Very good. Okay, so if we do that, it's going to print orange. And then we can also append to our list of fruits. We can add another fruit, strawberry. Strawberries are delicious. And then we could just print the whole list of fruits. That works. Python will let you do that. And now you can see the list includes strawberry now. So append is how you add to a list. And you use the name of the variable that the list is in, the dot, and then append. That might seem weird. You're going to understand why in a minute. We might go a little bit over time because we started late. I hope everyone's okay with that. So is everyone good? Cool. All right. Moving forward. Lastly, another thing you can do is, sorry, two more things actually. You can change the contents of fruits. So I can say, hey, the first item in fruits, I want to change it to cherry. I want to assign the first item in fruits to cherry. You can do that, like I've written here. And you see now banana has changed to cherry. Okay? Does that make sense? So the square brackets allow us to access an item in the list. And then lastly, we can remove an item. You can do del for delete, and we can delete fruits. Let's delete apples because I don't like apples as much. Apples are still good, but I like the other ones more. Oh, I need to print the list again. And then you can see apple is removed. Is everyone good? Great. And now dictionaries. I know we're going fast, but again, fast stuff. So my dictionary, we're going to do, we need an assignment operator. We're going to do, I don't know. We're all students today, so you get a grade of 100, and name is Beej, although I probably wouldn't get 100, but it's fine. And let's also, I don't know. I'm just going to make one called numbers. Typing is hard.
How about wearing hat, true or false?
Ooh, thank you. I mean, that one's always true. That shouldn't be a variable. That should be constant. All right. Whoa, aha, you need a comma. All right. So far, so good? I know it's a lot of typing. I apologize. Give me a signal when you're done typing, please. All right. So now, I still see some typing. Hey Sam, do you mind turning on the heater behind you? All right. Now we can do my dict, right? Square brackets, and then we can do, hey, autocomplete is great. We can get the name and we can print that, right? And what do you think that will do? What will that print? Correct. It'll print Beej. Okay. And similar thing, we could change, similar to lists, we could do my dict. Typing is hard. I'm getting really hungry. Oh man. I can change the name to Luke, because he's a cool dude. And then I could print the name again. and you'll see that it will change, right? Okay, no surprises there. Now, what if I want to get the second number in this numbers list? All right, we could just do, let me get my indentation, my dict, numbers, and then 1, let's say. Scroll up a little bit. There we go. Is that what will this one print out? What number is that? Correct. Excellent. Very good. All right. So does that all make sense so far? And then let's do a quick little loop. We can do for key value in mydict.items. And we can print key colon value, and it'll print each thing. There are other functions you can use with a for loop, but for now we're just going to cover items because we're getting tight on time. So far so good? All right. So, is anyone still typing? Yes? No? No? Okay, cool. All right, great. So, dictionaries are very useful when you need to look up stuff. Their search time is pretty fast, so don't panic if you have like a million items in your dictionary. It's not the end of the world. Okay? Now, on to absolute madness. Okay? Classes and objects. This is something called object-oriented programming. This is very common in many languages. If you've ever touched Java, this is the only thing you know. And object-oriented programming, I'm not going to have you write down all the stuff because it's going to take too long. I'm just going to burn through it really fast. Okay? You've actually already used it a little bit without even realizing it. Okay? Object-oriented programming is intended to model the real world. Okay? So you could define an object like a desk, okay? And then you could define a whole bunch of stuff to make it behave as closely to a desk in your code as you can imagine it. Now, it sounds really cool and fancy. It's actually kind of dumb when you see it. But it's really, really useful. And the way we do this is we have classes and we have objects. You can think of a class like a blueprint, like a classification of objects, okay? And then objects are the things that you make from those blueprints. Okay? So the common example I use is a class is a blueprint, an object is a building. Okay? The building is specified by the blueprint. And you can make 100 buildings from that one blueprint if you wanted. Same with classes and objects. Okay? Now, what makes an object an object? An object knows things and does things. Or another way you can think about it is an object has attributes and it can carry out actions. Okay? So, for example, using a chair, right? A chair might have an attribute like a color or a material. And it might have an action like move or fold up if it's a folding chair, right? These kinds of things. Okay? Now, how does this translate? Knowing things or attributes is just variables. It's just variables. And doing things or taking actions are functions. Very simple. Now, there's a whole bunch of principles, right? Encapsulation, inheritance, polymorphism, and abstraction, right? If you get really into like computer science stuff, you can rattle those off the top of your head. Unless you've been doing it for too long and forgotten them, like me, and I had to look at it. But they can help you really understand how objects work more deeply. We're not going to go deep into the stuff today. But I'll just quick review. Encapsulation means that if you have two objects, they have their own separate data. So this object's material is wood, and this object's material is metal. If you change either of them, they don't affect each other. Okay? Just like in the real world. Objects are separate. If you use something in one object, it doesn't affect another object. That's encapsulation. Additionally, you can also set the how public things are. So like anyone can change this, some people can't change this. That's more of a Java thing. There's also inheritance, right? And so like if you have a parent and they have brown hair, or let's say both parents have brown hair, what color hair is the child going to have? Likely brown hair, right? Unless, genetics is not that simple, but whatever. Same thing. You can have classes inherit from each other. And everything that the parent class has, the child class will copy unless you change it. Polymorphism. Let's say that I have a class like a vehicle, and then I have a child class like a car. Because the child class, car, has everything that the parent class has due to inheritance, I can treat a car like any other vehicle, right? Because it's guaranteed to have everything the vehicle has, okay? And then abstraction is, I don't need to know every little thing about how an object works. I can just use its functions and attributes. So for example, a car. Do you know how a car works internally? Not really. Like some bits here and there, sure. But you don't know every little piece. You've just abstracted away that if I push the pedal, it goes. That's abstraction. Okay, you don't need to know the inner workings to understand how it works. Or to understand how to use it, sorry. Does that make sense? Cool. It gets deeper than that, but at the highest level, that's sufficient. So what we're going to do, is I'm not going to have you type this out because it's going to take too long, okay? Also, I'm going to share this presentation in our Discord. There's also going to be a YouTube video. You can reference it later, okay? So I'm just going to explain this. We're not going to type it. To create a class, use the class keyword, okay? And then you do the name of the class, exactly like a function, right? Def add class vehicle, cool. And then a colon to say, okay, now we're going to define the contents of the class. Again, just like a function, okay? Now, classes have functions inside them, okay? There's a special function called init, short for initialize, okay? This init function, when you create an object from that class, it executes this init function, okay? When you see this underscore underscore and then an underscore underscore afterwards, that's what we call a magic function in Python. And they're usually reserved functions, or not reserved, but they're like predefined functions by Python. And they get executed at magic times. You don't explicitly call them, doing something calls them. So for example, when we did the plus, first number plus second number, surprise, that's actually a function. There's a magic function called underscore underscore either plus or add, I forget which. And when you use the plus symbol, it actually calls that magic function on the first object. So it did first number dot underscore underscore add or plus. I don't remember. Underscore underscore and then parentheses the second number. Everything's functions under the hood. But in any case, magic functions underscore underscore. When you see an underscore underscore function, go look it up because it's called at a time that you don't know. And you just have to go memorize it. So init is called when you create a new object from a class. And yes, we're going over time. We're almost done, I promise. Now, for the knowing things, right? If you want to define an attribute on an object, or if you want the object to know something, you have to use this. Where did my mouse go? Okay. You have to use this self here. Whoa. Self basically means we're defining it on the object. Okay? So self.wheels means that the object is going to have an attribute called wheels. Okay? And every function has to start with self. Okay? Because otherwise it doesn't know where it comes from. Okay? So every function has to have, technically no, there are like class functions and static functions. We're not covering that today. But your methods must include a self parameter, and then that's where you define your attributes. Okay? So in this, a vehicle can take in a count of wheels, right? And then on the object, we set an attribute called wheels to whatever is in count wheels. And the same with color. So then later when we, I don't have, I didn't have an example of a vehicle. But if I did my vehicle equals vehicle, parentheses, you skip self, and then I could, maybe it's like a 6-wheel vehicle, right? So I could just put 6 and then red or whatever, and it would work. Okay? Now, when you want to access the value in an object, use the dot. Remember when we did fruits dot append, lists are actually an object. Okay, and the list object has a function defined called append, and that adds an item to the list. Okay, so same thing. You can define a whole bunch of functions in a class that you can then use on objects made from that class. Okay. And then you can have inheritance. So I mentioned the car and vehicle example earlier. If you want one class to inherit from another, you just use parentheses and then put the name of the parent class. So car inherits from parent, or car inherits from vehicle. So then car has everything that a vehicle has. And if I want to use the vehicle's constructor, the vehicle's init function, I just do this nonsense right here. You can just memorize it, copy, paste, whatever. And then I say, okay, a car only has 4 wheels, so I'm going to hard code count wheels to 4, and then I'll take in whatever color that I get from whoever's constructing it. Okay? So then if I create a new car with the color blue, right, the number of wheels is hard coded to 4 here, and then the color is going to get set to blue. So if I run this, it's going to print 4 and it's going to print blue. And then to demonstrate encapsulation how objects are separate, if I create a new variable and I construct a new car and I set the color to black, the color will be black instead. And then this would still be blue if I printed it again. Does that make sense? Great. I'm not going to go too deep into this because when you're just starting out, you're probably not doing a lot of this. And later on, when you do this stuff, you're probably following some kind of framework and they're going to do a lot of hand-holding for you. Okay? And also, we're in a hurry. We only got like 4 minutes left. And it's not enough time. So we're just going to burn through this stuff. Okay? But I have the example code for all this online. I'm going to share that with you guys. Okay? Now, modules. So we're going to come back to your question from earlier. Modules are basically code that's pre-written that you could just use in your current code. Okay? So, for example, we mentioned CSV files. Okay, here, let me go ahead and grab this guy. Where is it? Wait, why did I put meddas in quote sol? Did I put in my personal? I put in my personal repository. All right, I'm going to move it to code sol. Sorry about that. 1 second. Let me. I want to show the CSV file. There we go. Cool. So this is what. No. I want the raw file. So this is what a CSV looks like. Make this bigger. Okay. Comma separated values. Each line is a record, and then the commas separate the columns. So you can basically view this as a spreadsheet or a table like you see here. Okay? So this is a CSV. This is very commonly used in data analysis, in AI training, all this kind of stuff. Okay? So this is just a work log. Okay? So it's like date, the employee, how many hours, and then the thing. And then what they're working on. Okay? Thank you, Habiba. CSV is a library of code, a whole bunch of code that's already written, that's actually built into Python. Okay? And this CSV code knows how to read CSV files and do stuff with them for us. Okay? So what you can do is, you can say, hey, let me open this CSV file, all right? and then let me open it with the CSV library to pull the data out. Okay, so if let me pop over to my example real quick. Okay, uv run csv example.py. Oh my god, typing is hard. Cool. What you can see here is we have this CSV file, right? No. And then using, oh, that's gross. Let me fix that. Yeah. Let me, let's not do this. Sorry, 1 second, guys. 1 second. I want this to be readable. There we go. So basically what we do is we read the file, okay? We tell it, hey, treat the file like a dictionary, right? Where each column is a key, and then each row has the value, right? So if we look here, you can see that we have a date column. So I have a dictionary with the key date, and that's the first value. I have a column here, employee, same thing. I have a column here, hours, same thing. Okay, you get the idea? And so what you can do is it makes a list of dictionaries, right? We talked about nesting earlier. And then I can do stuff with that. So I can calculate, hey, for each record in the data, if the employee is Bob, go ahead and track the total number of hours and then print those hours. So in total, Bob has 31 hours of work. All right, so you can do data analysis with this kind of stuff. And, you know, I could write a whole bunch of code to open the CSV file, to read when there's a comma, when there's not a comma, to create a dictionary and all that. Or I could just use a module to do that for me. Okay, so that's what modules do. Now, the question about variables earlier, when you define a variable like here, data, right? Data only exists within this module. And a module is usually a file. Okay? So there's actually a CSV file somewhere in Python. And we're just saying, hey, give me that code. Okay? But that's a more advanced thing. I don't want to go into details about it. And then, last but not least, right? Yes. Yeah, because we're a couple minutes over even my other estimated time. So I talked earlier about pyproject.toml, right? You use that to manage your Python project, right? Here you can define dependencies because maybe Python itself doesn't have all the code you need. For example, you need to connect to some new database out there, right? Python doesn't have the code to connect to that new database, but you're not going to write it yourself. But someone else wrote code to do that, and you want that code. So how do you do that? There's a website, pypi, pypi.org, the Python package index. And so let's say I wanted to connect to MySQL, a database, right? I could just search for MySQL, right? And then there's a package. Well, here's a package, really, where this has code to connect to MySQL using Python. Okay? So what I could do is I could just grab the name of this, and I could toss it into my pyproject.toml as a dependency. Oh. I think that was how it was written, right? Yeah. So I could just toss it in here, right? And then, once I have my dependencies defined, I can do uv sync. And then, well, there's a problem with this specific package, but it'll download that code for me, and then I can just use that code in my project. Okay? So that's super, super useful because then that saves you a bunch of time. You can just grab code from this person, grab code from that person, and you're good to go. All right? So, yeah, you can use PyPy to go find modules that you need, and use UV sync to download them, and then you can start using them. So I have an example in this project of using polars to analyze, which is a really fancy data analysis library. I use polars to analyze the CSV file, but we are out of time, so I'm not going to burn time on that. But the code is online. I'm going to share it on the Discord. There's also the YouTube video. If you search on YouTube for Code Sold, you'll find this video. So yeah, I apologize for going over time. If my damn power adapter had not caught fire last night, it would have been fine.
Yeah.
But thank you guys for your patience, and I hope this is useful. I'm sorry we didn't get all the code written that I wanted to, but we also had some environment issues, plus, yeah. Anyway, fewer excuses, more progress. So, yeah, this QR code is our Discord channel. You can ask questions here. You can ask for help. You can just talk. We have a whole bunch of off-topic channels to just chill and talk about nonsense as well. If you want to tag me on there, my name is The Beej. Also, we are a non-profit a non-profit company. And right now we're not spending, we used to pay for food for everyone for these kind of events, but well, I don't have that kind of money anymore because I was the one bankrolling the whole thing and now I don't have income. So what we would like to get back to paying for food for people or paying for other things. There are certain events we want to have, so if you want to donate money, that goes to our company, and we'll use it for various types of events. We do want to do things like hackathons and career fairs and all that in the future, but it requires money. We also may want to have like guest speakers who wouldn't come unless we paid them, so that kind of stuff. But yeah. However, if you are not working right now, if you're not receiving income, don't send donations. We don't want your money, okay? But if you're gainfully employed, yes, give us your money. And that is only spent on the meetup. That doesn't pay me. That doesn't pay our other volunteers, this kind of stuff. So yeah, hope to see you guys on there. Thank you, everyone, for coming. Also, after events like this, we usually go out and grab food together. So if you want some food, probably chicken, stick around. We'll go grab some food, and we'll have a great time. Thank you for your patience, everyone. I hope you got a lot out of this. Please do share feedback with us, especially you people on YouTube, and also share feedback with us over food or even on Discord. And thank you again for coming, and good luck with Python.